In this video, we are going to understand data visualizations and basic workflow. So the importance of data visualization is we'll be transforming our raw data into meaningful insights. So we'll be basically identifying different trends, correlations, and outliers. So trends is nothing but whether the data is increasing or decreasing. So let's say an example of trend is global warming. So let's say we are calculating the temperature for every decades. Okay, so for that would include 10 years. So if you are calculating with respect to the temperatures, so the global warming has been increasing rapidly. So this is called as upward trend. So it will be identifying the trend once after visualizing. Then correlation. So correlation is nothing but the relationship between, let's say here we are considering with respect to years and temperatures. So it will identify how far the year and temperature are related. That is what called as correlations. Next is outliers. So outliers are the data that deviates from the normal values. So let's say the temperature has been between the range 50 and 70. And they are maintaining a proper pattern. So these data are called as outliers. So outliers are called as extreme data. So it will be identifying it. And it supports data-driven decision makings also. So with that, a proper insights can be taken and an accurate and a precise model will be built out of it. Then we are going to see the common data visualization techniques. So it usually includes scatter plot. So scatter plot basically analyzes the relationship between two different numerical variables. So in the previous example, we have seen years, which is in form of daytime, and then with respect to temperatures. So if you are plotting, it may be in this plot. So this is called as scatter plot. So it usually analyzes the relationship. Like if the years is increasing, the temperature is also increasing. So this implies that both the variables are correlated. They are positively correlated. So that relationship can be analyzed with the help of scatter plot. Next is box plot. So box plot usually look in this way. So this is nothing but a normal numerical values or a normal values. Then the data, this is called as lower bound and this is called as upper bound. So the data which is lesser than lower bound and the data which is greater than upper bound are considered as outliers. So these data are usually represented in this format. So with that, the outliers can be detected and they can be further handled. Because the extreme values has to be handled properly in building a proper model. Next is histograms. So histograms usually provide us the frequency distributions of a variable. So let's say you are plotting cholesterol. So it usually provides us different ranges because cholesterol by considering the entire data sets. So now let us understand. We are going to plot a cholesterol graph, okay? And here we'll be having count of people in y-axis and here we have different cholesterol levels. Let's say in our data set, it usually starts from 110, 120, 130 till 165 it may be. Then between 110 to 120, the people who are having cholesterol levels having a count, say 5. Here in our y-axis, we'll be having the count values. Then between 120 to 130 cholesterol levels, there are over 10 different peoples. Then 7 different peoples, then 3, then 2, and almost 15. Okay. So this is called as histogram plot. So we'll try to analyze how the data variation is, how the cholesterol level has been moving, whether it is normally distributed or not. Okay, we'll try to make some inference out of it. Next is heat map. So heat map usually provides us a color variations and it usually depicts the correlations between multiple features. So the relationship between the two variables can be analyzed using this graph and the proper values. The relationship values can be shown with the help of correlations. So it usually lies between the range -1 till 1. So -1 to 0, that implies that the data are negatively correlated. For example, consider temperature in x-axis and sales of sweater in y-axis. So when temperature keeps on increasing, what happens? The sales of sweater keeps on decreasing, right? So this is a normal part. Okay. So we'll try to analyze how they are correlated. So they are negatively correlated. We will be able to sell but how far they are negatively correlated? That particular value will be provided with the help of correlation. Let's say they are 0.80%. This implies that these two factors are 80% negatively correlated. So we'll try to understand each and every feature importances with help of it. So creating a workflow in Orange. So first step is we want to import the data using the file widgets. Then you have to connect to the data tables in order to preview the data, how the data look like, what are the columns under it, what are their data types of each and every columns. Then we'll be making use of visualization widgets. So directly once after converting them to a form of table, you can directly analyze the scatter plots or box plots, histograms, count plots. So many different plots are usually available. So with that, you can, if you want to find the relationship between the data, you can make use of scatter plots. If you want to detect the outliers, you can make use of box plots. Then in step 4, we can apply transformations if needed. Then once after connecting with those 5, once after visualizations, so we'll be interpreting the visualizations. So from that, what we can recognize. So we'll be identifying different patterns, whether they are positively or negatively correlated, whether we are having different outliers. So outliers are, in case of sensor data, they will be considered as an anomalies. So for example, if normal BP range is between 110 till 130, if the value deviates like 140, this implies that this is an outlier data or an anomalies. So with that, we can come to a conclusion. So detecting anomalies and inconsistencies. Then we'll be comparing the distributions across different categories. So how far the values have changed. So how about with respect to target column? Let's say 1 implies that the person is having heart disease and 0 implies that the person is not having heart disease. So when you are plotting a cholesterol level with respect to 2 different categories, or let's say you are visualizing a bar graph. Okay, so for the people who are having heart disease and who are not having heart disease. So likewise, if you are analyzing with the help of bar graph, you will be coming to conclusion that what is the mean value of the cholesterol levels on 2 different categories. So we'll be comparing distributions across the entire table. So that would be the end of data visualizations and basic workflows. Thank you. See you in next video.